Hi everyone, I'm Ramir Maheshwari,
And I'm Shanmuka Srinivas.
and we did our presentation on applications of physics in basketball.
Our first application was spinning a basketball on our finger. We envisioned the point of contact between the finger and basketball as a circle, and we consider a point on this circle to be like a car. So assuming air friction is negligible, when the car spins around the circle, a centripetal force from static friction acting towards the inside of the circle keeps the car in nearly constant velocity and uniform circular motion. Gravity and normal forces are equal and opposite. Therefore, the ball does not move in the vertical position. Therefore, static friction is a net force acting inwards, keeping the ball on your finger. For our second application, we analyze the forces acting on a basketball player, me, as a second basketball player, Ramir, pulls on me as I jump. During the instant I jump, four forces are acting upon me. As always, gravity is acting downwards upon me. By pulling me, Ramir is exerting a tension force pointing diagonally downward. By jumping in a forward motion, I exert two forces on the ground, which by Newton's third law exert an equal and opposite reaction force to me. The first force is friction. As I jump diagonally, I exert a diagonal force on the ground, which exerts an equal and opposite static friction force. The second force is the normal force. As I jump, I slightly lean backward, thereby explaining the diagonal direction of the normal force. The sum of the vertical components of friction and the normal force must be greater than gravity and tension, as I am accelerating upward at the point of the jump.
For our third application in the real world for physics, we chose to analyze a free throw shot. In this case, we see the basketball being shot at an angle at the hoop. As you can see, the basketball makes a curve, a parabolic curve. This is known as projectile motion. The basketball was shot at an angle, which means it had a vertical and horizontal velocity. However, assuming air resistance is negligible, the acceleration horizontally was zero. It was moving at a constant speed and velocity horizontally. Vertically, however, it was decelerating and moving downward due to gravity, which is why the curve is parabolic. That is the only force acting on this ball. For our last analysis of physics in basketball, we chose to analyze the jump stop. As you saw in the video, the player in the red basically was running fast, and then he made a sudden stop and he shot the ball and made the basket. What he basically was doing was he was using and taking advantage of static friction. The direction of his movement was to the right, and because of static friction, he was able to suddenly stop and then make the basket. Static friction was acting in the opposite direction of him. His normal force and gravity were equal in opposite directions. There was no movement vertically. He was simply able to decelerate at a very quick pace because of static friction. And that's how he made the shot.